Hello, class. This video is going to review fractions. This should help you be comfortable with fractions. I know that fractions have been a sticking point in the past for a lot of people, and I want to show you everything you're allowed to do and why it works. So, as always, please email me if you have any questions. What is a fraction? First off, I want to understand fractions. It's an indicator of division. So when I write 1/4, I just mean the same thing as 1 divided by 4. The fraction bar just means division. Now, how does 1 divided by 4 work? I can divide 4 into 1. Now, 4 doesn't go into 1, so you might think we're done. But remember that 1, 1 is the same as 1, 1, and 0 tenths, and 0 hundredths, and 0 thousandths, and so on. You're allowed to add decimal zeros to a number. So 4 goes into 10 2 times. Since the 2 is above the 0, like the 0, the 2 is in the tenths place. So I'm copying the decimal point up here so that I remember that my answer starts in the tenths place. Okay? Now 2 times 4 is 8. 10 minus 8 is 2. Bring down the 0. 4 goes into 20 5 times. 5 times 4 is 20. We get a remainder of 0. So 1 divided by 4 is 0.25. And if you'd like to write that as a percentage, remember we can move the decimal point 2 places over and call that 25%. So 1/4 represents 25% of something. And the second way to think about a fraction is it represents part of a whole, any number that isn't a whole number. So I could think, here's one whole object. You could think of cake or pizza. We're going to cut that into 4 pieces and just take one of the pieces. So there's 1/4, 25% of the pie. If I wanted to write a fraction like 3/8, I could think of that as 8 goes into 3 how many times? 8 goes into 33 times. 3 times 8 is 24. 8 goes into 67 times. And it goes into 45 times. So 3/8 is 0.375. You could call that 37.5%. Or you could just think of a pizza that's been cut into 8 slices. And 3/8 refers to 3 of those slices. Okay. Next idea. A fraction represents a proportion. So when I write 3/8, the 3 is called the numerator, tells how many of the thing you have, and the 8 is called the denominator, tells how many pieces the thing is divided into. So 3 tells how many pieces you have, and 8 tells how many pieces a whole is divided into. In essence, we're taking a whole, we're dividing it into 8 parts. So here's one of those 8 parts. And then we're going to multiply one of those parts by 3. So go from 1 part to 3 parts. And there you've got 3/8. So the numerator is multiplying and the denominator is dividing. We can also think about a fraction as a proportion. When I say 2/3 of 63, what does of mean in math? You might know that of means multiply. So if I said that each box has 6 cans and I brought 2 of the boxes, when I said of here, you know that I have 12 cans, and that's because 2 of the 6 can boxes means 2 times 6. So when I write 2/3 of 63, we're going to multiply 2/3 and 63. Okay. Let's talk about 2/3 for a second. This is a fraction with a numerator and denominator, and the numerator means multiply and the denominator 3 means divide. So I want you to know that you can rewrite this fraction as you please. You could call it 2 times 1/3, or you could call it 1/3 times 2. It's a fraction that's cutting something into 3 parts and then taking 2 of those parts. So we're going to write it however makes the most sense for us. In this problem, 2/3 times 63, we could write 2 times 1/3 times 63. And then multiplication doesn't care what order you do it in. It's called commutative. We can write that 1/3 of 63 is 21, and 2 times 21 is 42. How did I know that 1/3 of 63 was 21? I did that in my head, and here's how. 1/3 times 63. I used a trick called distributing. I know that 1/3 of 63 is 1/3 of 60 plus 3. Well, that's 1/3 of 60 plus 1/3 of 3. So that step is called distributing the 1/3 into the equation. 1/3 of 60 is 20, and 1/3 of 3 is 1. So 1/3 of 63 is 20 plus 1. It's a number trick I like to use, distributing. Okay, so if I had to write what is 5/8 of 64, I don't want to multiply 64 by 5 right away. You might have learned in school to do it like this. 64 is the same as 64 divided by 1, and then we multiply across. I think it's easier to say 5/1/8 of 64. 1/8 of 64 is 8. And 5 times 8 is 40. For me, that's the easiest way to solve these problems. You get to apply the fraction piece by piece in whatever order is easiest for you. Okay. Let's think about multiplying fractions together. Let's say you had to do 2/3 of 3/8. One way to think about this is the second fraction is my pizza, cut into 8 slices, and I have 3 slices. So just think I have 3 slices of pizza, and now the 2/3 is going to be a proportion. I want 2/3 of the red part of the pizza. So 2/3 of 3 is going to be 2. There are many different ways you can solve this problem. So, but one way, the way we just described here, is 2/3 of 3/8 will be 2/8. If you liked the method we used for 5/8 of 64, you could also write 2 times 1/3 times 3 times 1/8, and that's the same. We get to multiply these in whatever order is the easiest for us, and here I noticed that 1/3 of 3 is 1. So now I have 2 times 1 times 1/8 is 2/8. Many different ways to play with these fractions. You get to break them up as you see fit. Okay. Now, what should I do if I have to say 1/2 of 1/3? So when I write 1/3, I take my pie, and it's a small pie, so I cut it into 3 equal pieces, and I wanted to eat one of those pieces. But 1/2 says we want just 1/2 of one of these pieces. So we're going to cut each piece in half. There were 3 pieces, but now there's twice as many. So 1/2 of 1/3. How many pieces are there? Twice as many as 3 pieces. So it seems what we should be doing is multiplying the 2 times the 3. And that's how we get this answer of 1/6. And so the trick they taught you in school, less of a trick, more of just a method. Now I've shown you why this works. Looks like the bottoms get multiplied too. In the future, if I had to do 3/8 of 4/5, I can just write 3/8 times 4/5. The 4/5 is going to get divided into 8 pieces, which means I can multiply the 5 times the 8. And then they're going to get multiplied by 3, which means I can multiply the 3 by the 4. Everybody in the numerator is multiplying, so they go together. Everyone in the denominator is dividing, so they go together. I got 12 over 40. Okay, here's the thing. When I get an answer like 12 over 40 or 2 over 8, I am not done. Let's look at this fraction 2 over 8. I need to reduce the fraction. They told you in school what you need to do is look for a common factor of 2 and 8. So I could notice that I have 2 times 1 over 2 times 4, and I'm supposed to cross out these 2's because they match. And so 2 over 8 is worth 1 over 4. Now it turns out both of those are worth 25%, but why does this work? Let's draw a picture. This pizza is going to be cut into 8 slices, and I want to eat 2 of those slices. When I reduce the fraction, what I'm noticing is that the number of slices I'm eating and the number of slices the pizza's cut into are both multiples of 2. So I didn't need to make so many cuts with the pizza cutter. I'll keep these cuts, but get rid of those. So I'm getting rid of the diagonal cuts and saying, now the pieces are twice as large, so I only need to take half as many to have the same amount of pizza, 25% of the pizza. The pieces are twice as large, there's 4 pieces instead of 8, and I only need half as many, 1 instead of 2. So 1 of the 4 pieces would be the same as 2 of the 8 pieces. That's what's happening when you're reducing a fraction. So now let's reduce 12 over 40. I'd ask, what do you see that goes into both 12 and 40? And you might say 2. 2 times 6 over 2 times 20. 6 over 20 isn't finished. Both of those numbers are still multiples of 2. 2 times 3 over 2 times 10. So I can reduce it again to 3 over 10. And that seems to be as far as it goes. If you spotted it right away, you might have noticed that 12 and 40 are both multiples of 4. 4 times 3 over 4 times 10. So our final answer should be 3/10. That way's a little bit faster. When I saw the 4 here, 4 is the greatest common factor. That means it's the largest number that divides into both 12 and 40, and that means that if we cancel out the 4, we'll be done in one step instead of multiple steps. So for very large fractions, it might be helpful to have a method to find the greatest common factor quickly, instead of groping in the dark for this factor of 2 and then this factor of 2 and so on. Let's look at a really large fraction. 105 divided by 490. I'd like to reduce this and write it in lowest terms. What's the fewest number of cuts I could make in a pizza to describe this quantity? I do notice that both of these numbers are divisible by 5, but I don't know if 5 is the greatest common factor. I just know it's a common factor. If I take out the 5, I believe we'd have 21 over 98, and then we'd have to keep going. Here's a way to get to the bottom of things more quickly. We're going to make factor trees. So 105 is 100, oops, that's not right, I'm sorry. 105 is 5 times 21, and 21 is 7 times 3. What do you know goes into 490? Well, it ends in a 0, so it must be 49 times 10. 10 is 2 times 5. 49 is 7 times 7. These numbers at the bottom here are called prime numbers. And that means they can't be divided any further. The only way to divide up 7 is 7 times 1, so there's no point. 21 is not prime because it breaks into 7 and 3. There's a point to that. So you break the fraction all the way down into prime numbers, and now we can write 105 over 490 is 3 times 7 times 5 divided by 7 times 7 times 2 times 5. To finish the problem, you cross out any number that appears both top and bottom. So 5 cancels with 5, and 7 cancels with 7. You're left with 3 over 7 times 2, and 7 times 2 is 14. So our final answer is 3/14. The factor tree let me get there all in one step of canceling instead of looking for factors one at a time, which for very large fractions is going to save me a lot of time. So now we know how to multiply and reduce fractions. Let's talk about how to divide. What if I had 25 twelfths? My pizza was cut into 12 parts each, extra large pizza, 12 slices, and we're going to eat 25 slices. We could do long division to find out we need two pizzas, two whole pizzas, and one extra slice. But what I'm interested in here is, let's say this meal is fit for 5 people. So we'll divide it by 5. I have 25 slices. I have to split them 5 ways. So we each get 5 slices. Seems one way to divide by a whole number is to divide the number out of the numerator. So that's how we can divide a fraction by a whole number. The other way that we could divide a fraction by a whole number is to say, sorry, one moment, is to say there's 25 slices, each slice is 1/12 of a pizza. Let's take each slice and split it 5 ways. It's not very practical, but if we take each slice and split it 5 ways, now there's 5 times as many slices, and we each still get 25 slices. Each of those is 1/5 of what we had before. So you could also say your answer is 25 over 60, where 60 is 12 times 5. I split each slice into 5 pieces. I keep saying pizzas. I split each slice into 5 pieces, and so there's 5 times as many slices. We each still get 25 slices because there's 5 times as many. There's enough for all of us. So you could divide the 5 out of the numerator or multiply the 5 into the denominator, and you get the same answer, because it turns out 25 over 60 is, 5 times 5 over 12 times 5. We can cross out the 5s and get the same answer as 5/12. So if a meal is large enough for 5 people, we divide it into 5 parts. How about this? We've got an extra small pizza. It was cut into 4 slices, and I ate 3 of the slices, but that was only enough for half of a meal. I'm still hungry enough to eat another one of those meals. I could eat 3 more slices. If the 25 slices is enough for 5 people, we can split it 5 ways. If the 3 slices is only enough for half a person, we could split it 1/2 ways. We can write 3/4 divided by 1/2 to say, I'm dividing this food into portions, but this is only enough for half of one person's meal. If I need another meal of the same size, this was only half of my meal, I need twice as much food. So it turns out that dividing by 1/2 is the same as multiplying by 2. Okay? Dividing by 5 is the same as multiplying the denominator by 5. Dividing by 1/2 is the same as multiplying the numerator by 2. We would get 3/4 times 2 over 1, which is 3 times 2 over 4 times 1, 6 slices. Dividing by 1/2 is the same as multiplying by 2. This leads us to the fastest way to divide fractions, a trick you've heard before probably, called keep, change, flip. Okay, let's say I had 7/8 of a pizza, and that was enough for 3/4 of my meal. The fastest way to get our answer is to keep the 7/8, change the divide into a multiply, and flip the 3/4 into 4/3. Dividing by 1/4 is the same as multiplying by 4. Dividing by 3 is the same as multiplying by 1/3. Now to multiply these, we do 7 times 4 over 8 times 3. If you like, you can cancel before you multiply. 4 over 8 is the same as 1 over 2. I took a factor of 4 away from both. That gets me my answer a little faster, 7 over 6. Excuse me. 2 times 3 is 6. All right, so that's how we can divide fractions. Up next, we need to be able to add and subtract fractions. Turns out the skill is the same. If I have to do 1/2 plus 1/3, it's not simple like multiplying. The problem here is that I'm adding one of this and one of those, but the things I'm adding are not comparable. 1/2 is larger than 1/3, so I can't say I have 2 slices because my 2 slices are different size. I need some way to compare them directly. If you stare at these pizzas for a moment, you might notice you can cut the right pizza, cut each slice in half. With the left pizza, you can cut each slice into thirds. Now both pizzas are made of sixths. The left pizza is 3/6, and the right pizza has 2/6. So we can add them together directly and make 5/6 of a pizza. And that's the correct answer. The way that you did this in school, they would have told you to get a common denominator, by which they mean with 1/2, we're going to multiply by 3 over 3. That does not change the value of the fraction. 3 over 3 times 1/2 is 3 over 6. You know that both of those are 50%. The reason that works is that 3 divided by 3 is 1, and multiplying by 1 does not change the value of a number. So it's a fancy way to multiply by 1, and what it refers to in the pizza is saying, down here, there's going to be 3 times as many slices, and we will take 3 times as many slices. So instead of a pizza cut into halves, where we take 1 slice, the pizza's cut into sixths, and we take 3 slices. That's the same amount of pizza. With the 1/3, we're going to make twice as many slices and eat twice as many slices. So instead of eating one of the 3 slices, we will eat 2 out of the 6 slices, and that's the same amount of pizza. Now that all our slices are the same size, sixths, we can compare the two. 3/6 plus 2/6 is 5/6. So again, but a little bit faster, if I had to do 1/3 plus 3/4, I would get a common denominator by cross multiplying. I would take the denominator 4 and put it over here. Take the denominator 3 and put it over there. 1/3 is the same as 4 times 1 over 4 times 3. 3/4 is the same as 3 times 3 over 4 times 3. Both pizzas are in twelfths, and 4 plus 9 is 13. So we ate 13/12. That's called cross multiplying. Sometimes cross-multiplying is not the most efficient way to get the answer. If I had to do 1/8 plus 1/16, I don't want to put 16s on the left and 8s on the right, because that's going to make 16 128ths plus 8 128ths, which is 24 128ths. And now I need to make a factor tree and reduce this fraction. That's not the most efficient way to get the answer. We could notice 128 is a common multiple of 8 and 16, but it is not the least common multiple of 8 and 16. The smallest number that has both 8 and 16 as a divisor, the least common multiple, is 16. If one pizza is cut into eighths, and the other pizza is cut into 16ths, I only need to cut the eighths in half to make two pizzas both cut into 16ths. All we have to do is turn 1/8 into 2/16. And we get 2/16 plus 1/16 is 3/16. That's the same answer you'd get if you reduced 24 over 128. But we got there faster because we went straight for the least common multiple. Okay, so what if I had something like this? I need to do, let's say, 15 30-seconds plus 9 40ths. Okay? If I cross multiply with 40s and 32s, I get a denominator that is 4 digits. I do not want that. Let's think about 32 and 40. What's the largest number that goes into both? 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. So a 32 is just 5 2's multiplied together. 40 is 8 times 5. 8 is 2 times 2 times 2. So the most they have in common, their greatest common factor, would be 3 2's. Aside from these 3 2's, they have nothing else in common. Did you know that the greatest common factor and the least common multiple are connected? Here's how you can get from one to the other. I'm going to make a diamond diagram. 32 and 40 both have a greatest common factor. Together they have a greatest common factor of 8. 8 times 4 is 32. 8 times 5 is 40. I'd like to finish the diamond and put a number here to represent the least common multiple. I know that I have to be able to get there with the top set of arrows or the bottom set of arrows. So let's make both arrows worth the same. If the top has a 4 and we put a 5, together that's 20. If the bottom has a 5 and then we put a 4, together that's multiplying by 20. 4 times 40 has to be the same as 5 times 32, because both are 8 times 20. So 32 times 5, I don't know that in my head, but 40 times 4 is definitely 160. And it turns out 32 times 5 is 30 times 5 is 150, plus 2 times 5 is 10, that's 160. So you get the same answer either way. What I did was copy the 5 over here and copy the 4 over there. So my least common multiple is 160. I'll do another one of these. 32 times 5 is 160. 40 times 4 is 160. So I have 75 over 160 plus 36 over 160. and that's 111 over 160. And since I did it this way, I do not need to reduce the fraction. Let's try another one. I have to subtract 7 45ths minus 10 over 81. Let's look for the greatest common factor of 45 and 81. Oops. 45 is 9 times 5. 81 is 9 times 9. So the greatest common factor would be 3 times 3. What's left is 3's and 5's. So our greatest common factor is 9. All right. 9 goes into 45 5 times, and it goes into 81 9 times. So if I do 81 times 5, or 45 times 9, I should get the same answer. I know 81 times 5 is 405. So my least common multiple is 405. To make the 45s, I'll do 7 over 45 times 9 over 9, which makes 63 over 405. To make the 1081s, I'll do 10 over 81 times 5 over 5, which makes 50 over 405. Now both pizzas are cut into 405 parts. 63 parts minus 50 parts is 13 parts. And that's the end of the problem. Let's do one more just to make sure we get it. How about small numbers? How about 1/8 minus 1/12? Can you see the greatest common factor? That's right, it's 4. 4 goes into 8 twice and into 12 3 times. So if I do 12 times 2, copying this 2, that should be the same as 8 times 3, copying this 3. 8 times 3 and 12 times 2 are both 24, and that's guaranteed to be the least common multiple, just as long as 4 was the greatest common factor. So I need to make 24ths. I'll do 3 times 8, as instructed by the diagram here. 3 times 8. And I'll do 2 times 12, as instructed by the diagram there. 3 over 3, 1/8 is the same as 3 over 24. 1/12 is the same as 2 over 24, so their difference is 1 over 24. It's that easy. All right. We're ready for the last part of this video. Let's talk about decimals. Some fractions are terminating. Look what happens when I do 8 divided into 1. 1/8. 8 goes into 10 once, into 20 twice, and into 40 5 times. And then I get a remainder of 0, so we're done. It's called a terminating decimal because we're done. It terminated the process. Other decimals are called repeating. If I wanted to do 1/3, I would divide 3 into 1. 3 goes into 10 3 times, making a 9. The 0 comes down and makes another 10. 3 goes into 10 3 times, making a 9. We get a difference of 1. The 0 comes down, making another 10. So we get another 3. And then we get another 10, which makes another 3. On and on forever. So 1/3 is the same as 0.3 repeating. That bar over the top means repeating. It's 0.33333333. The 3's go on forever. So some decimals terminate and other decimals repeat. If I wanted to do 1/6, look what happens. 6 goes into 10 once, but it goes into 40 6 times. As soon as it does, it makes another 4, which makes another 40. So we get another 6, and another 6, and another 6. The 1 doesn't repeat, but the 6's do, so we write the decimal like this. Just the 6 is repeating, not the 1. On the other hand, if I had to do 2/11ths, I would divide 11 into 2, and look what happens this time. 11 goes into 20 once, making 90. 11 goes into 90 8 times, making 88, which the difference is 2. We're back where we started. 11 goes into 20 once, and then 11 goes into 90 8 times. And so we get a repeating pattern of 1s and 8s and 1s and 8s on forever. And so 2/11ths is written as 0.18 repeating. See, for 1/6, the 6 is repeating and the 1 is not. For 2/11ths, both digits are repeating. That's the difference between 0.166666 and 0.18181818. Okay, you can turn repeating decimals back into fractions. Also terminating decimals. Terminating decimals are really easy. If I see 0.625, I would say to myself, that's the same as a number divided by 1,000. It's the same as going 3 decimal places. So it's the same as 625 divided by 1,000. To divide 625 by 1,000, I just move the decimal 3 places to the left and get the decimal 0.625. So 0.625 is 625 divided by 1,000. We can reduce that fraction. 125 divided by 200, keep reducing. 25 divided by 40, keep reducing. 5 divided by 8. 0.625 is 5/8. I could have used a factor tree to reduce that faster. 625 is 25 times 25, so it's 4 5s all multiplied together. 1,000 is 10 times 10 times 10, and each 10 is a 2 and a 5. So we can cancel out 3 of the 5s and get 5 divided by 2 times 2 times 2, which is the answer I have here. If I see a decimal like 0.26, I see 2 digits, so I know that that's 26 divided by 100. We can only reduce a little to 13/50. So that's where we stop. If I see a decimal like 0.4, I only need to go 1 digit, so that's the same as a 4 divided by a 10, and we can reduce that to 2/5. So with a terminating decimal, that's all you do. If I had 0.16, I would say that that's 16/100, and 16 is 4 times 4, which is 2 times 2 times 2 times 2. 100 is 10 times 10, which is 2 times 5 times 2 times 5. So I'll cancel out 2 pairs of 2's and get cancel out 2 pairs of 2's and get 2 times 2 over 5 times 5. It's 4/25. So you divide by a power of 10, where the number of zeros is how many digits you see. Even if you had a very large, like 0.1024, you would say, okay, I went 4 digits, so that's 1024, 1024 divided by a 1 with 4 zeros. That's how many digits I had to hop over to make a whole number. And then we'd reduce the fraction. In this case, that turns out to be, we can cancel out a factor of 16, leaving behind 64. Don't ask how I did that in my head. Okay, ask how I did that in my head. A 10,000 is 4 2s and 4 5s. 1,024 turns out to be, and I had this fact memorized, excuse me, 10 2s multiplied together. So I just took away 4 of the 2s, leaving 6 2s behind. 6 2s makes 64, and 5 to the 4th makes 625. That's how I did that in my head. Okay, did you know that there's a trick like this for repeating decimals? It turns out if I had 0.3 repeating, I have to go 1 digit, and this time I'm going to divide by 9 instead of 10. 0.3 repeating is 3 over 9, which is 1/3. That's the answer we had up above. Did you know 0.4 repeating is 4/9? You can double check that. 9 goes into 4 how many times? Well, it goes into 40 4 times, making 36, leaving behind 4, which makes another 40, which makes another 4. So 9 divided into 4 makes 0.4 repeating. Seems like this works. If I had 2 digits that both repeat, instead of 9, I would do 99. 18 over 99 is 2 times 9 over 11 times 9, so that makes 2 over 11. That's the same answer we had up above. If I have 0.54545454 on my calculator, I would recognize that as 0.54 repeating and call it 54 over 99. There's 2 digits, so I write 2 9s. Then I can reduce that. 54 is 9 times 6, and 99 is 9 times 11. So 0.545454 is 6/11. However many digits you have, that's how many 9s you write. So if you had a 0.148148148, that's okay. 148148148, we're going to call that 0.148 repeating, which means it's the same as 148 over 999. Here, factor trees are going to save our skin. 999 is 9 times 111, right? 111 is divisible by 3, so let's divide it by 3. Turns out you get 37. 3 times 3 times 3 times 37. 148, I don't know, it's divisible by 2, right? 100 divided by 2 makes 50. 48 divided by 2 makes 24. 50 plus 24 is 74. 74 turns out to be 2 times 37. So both of these numbers have a 37 in common. You get 2 times 2 times 37 over 3 to the 3rd power times 37, and the 37s cancel out. 0.148148148 is 4/27. That's how you can turn any repeating decimal back into a fraction. If I do 1/7, this is too much fun not to show you. Watch closely. 7 goes into 10 once. 7 goes into 30 4 times. 20 twice. 60 8 times. Into 40 5 times. Into 50 7 times. And then we're back at 1. 7 goes into 10 once, and the whole pattern repeats forever. So 1/7 is 0.142857, all repeating. If you reduce the fraction 142857, since there's 6 digits, we need 6 9s. it turns out that this fraction will reduce all the way down to 1/7. We would need quite the factor tree to make it happen, but it's true. Okay, one more order of business before we're done. Some decimals don't repeat right away. How can I find out what those are worth? For example, we saw above that 1/6 was 0.16666, or 0.1 and then 6 repeating. So I don't get to use my 99s trick here. Here's what I'm going to do. We'll do a little algebra. X is 0.1 and then a bunch of 6's. If I multiply both sides by 10, on the left I get 10x, and on the right I get to move the decimal one place to the right and call it 1.6 repeating. Now if I subtract 1 from both sides, so first I multiplied both sides by 10, now I'm going to subtract 1. It says 10x minus 1 is 0.6 repeating. Now I can use my repeating decimals trick. 0.6 repeating is 6/9. 10x minus 1 is 6/9, which we know reduces to 2/3. So 10x minus 1 is 2/3. Add 1 to each side. 10x is 1 plus 2/3. You could call 1. How do we do 1 plus 2/3? You could call 1 divided by 1. The least common multiple of 1 and 3 is 3, so 1 is the same as 3/3. 3/3 plus 2/3 is 5/3. So 10x is 5/3. Now divide both sides by 10. X is 5/3 divided by 10. What should I write? Times 1/10. Dividing by 10 is the same as multiplying by 1/10. If you multiply both sides by 1/10, 10 times 1/10 is 1. So that works. X is 5/30, which reduces to 1/6. And that's the correct answer. Okay. So any decimal that's part repeating and part terminating, you can turn into a fraction with this method. Let's try it 1 or 2 more times. Let's say I ran into 0.533333, and my homework is saying, give me an exact answer as a fraction. Well, I did the problem as a decimal, shame on me. So I need to turn my answer into a fraction. It's a 5 and then a 3 repeating. I'll say x is what I want. 10x is 5.3 repeating. So 10x minus 5 is 0.3 repeating, which is 1/3. Now I'll add 5 to each side. 10x is 5 plus 1/3. Get a common denominator. 5 is 15/3. So 10x is 16/3. Divide both sides by 10. X is 16/30, which reduces to 8/15. There's the exact answer in lowest terms. 0.533333333 is 8/15. We can turn any decimal back into a fraction, as long as it's terminating or repeating or both. So one more, really tough one this time. You got the answer from your calculator, 0.29166666666, and presumably the 6's go on forever. We want to change this into a fraction in lowest terms, and we don't know what fraction we're going to get. So this time the repeater starts after 3 non-repeating digits. So to get the repeater by itself, I multiply both sides by 1,000. 1,000x is 291.6 repeating, and sorry about that. I hope you can still see me. Oh, notes crashed. Okay, well, looks like we're ending the video. That problem was so good. I don't want to not do it. Let's try one more time. X is 0.29166666666. So we multiplied both sides by 1,000 because I needed to move the decimal over 3 places to get the repeater by itself. Then I can subtract 291 from both sides. I know 0.6 repeating is 2/3. Now I can add 291 to both sides. What's 3 times 291? Looks like it's 873. So I've got 1,000x is 875 over 3. We'll multiply both sides by 1 over 1,000. X is 875 over 3,000. And then we can reduce the fraction. 875, that must have a 5 in it. If I divide out the 5, I get 175. Is that right? Yeah, that's right. 175 must have a 5 in it. If I divide out the 5, I get 35, which is 5 times 7. Meanwhile, 3,000 is 3 times 1,000, and we know 1,000 is 3 2s and 3 5s. That's because it's 3 10s. So we cross out all the 5s, and we get 7 over 3 times 2 times 2 times 2, which is 7 over 24. You can check that in your calculator. 7/24 really is 0.29166666666. So that's how you can turn any decimal back into a fraction. All right, hope you've enjoyed today's video. I will catch you next time.